Good day, everyone. My name is Joshua Viers, and I'm a professor at the University of California, Merced, where I also serve as the Associate Dean for Research in our School of Engineering. I'm happy to be affiliated with CITRIS, the Center for Information Technology Research in the Interest of Society, and the Banatow Institute, as it pursues new outcomes in ag-food tech. If you don't know much about UC Merced, I encourage you to check us out. We're very young, having opened our doors in 2005. We're now almost to 10,000 students, and we were the fastest to ever get to Carnegie R2 designation. Today, I'm going to talk to you about AI for ag in the San Joaquin Valley, and specifically about using inclusive innovation to break the productivity paradox. And that paradox, in fact, is that the San Joaquin Valley is one of the most productive agricultural spaces in the United States, and yet is also one of the most persistently poor. And so as we move forward with innovation in ag-food tech, we want to make sure that our underserved communities not only benefit from our technology, but also from our other successes. Before I begin, I want to certainly indicate that there are a lot of other people who are responsible for this work. The newly funded Artificial Intelligence Institute, funded by USDA and in affiliation with the National Science Foundation, that's the Agricultural AI for Transforming Workforce and Decision Support, or AgAid. An important aspect of our activities are around adoption and technology transfer, but notably around broader impacts. And so we have specific thrusts in and around extension and workforce development, and our broadening participation really is focused on inclusivity. On to water allocation intelligence. In California and elsewhere, obviously the opportunity to embed artificial intelligence in our thinking is not just from that initial communication and integration with sensor networks and machines and edge analytics and computation, but how we capture, process, and transmit decisions, not just data, and then ultimately turning that into operations. So our approach is adopt, adapt, amplify, in so much as that we adopt artificial intelligence by design initially, and then we adapt to the changing context, the environments, and the scales at which we're operating, and then ultimately amplifying those insights into human skills and efficiency in operation to close the human AI partnership loop. As we move forward with our designers and researchers and stakeholders, we're focused on generating next generation of scientists as well as a workforce. In the water allocation sector, it's important to recognize that we're all dependent on water for life. We understand that socioeconomic interties between infrastructure and downstream communities relies on a significant level of engineering, a hardscape, if you will, that is not as often informed by data. And so we're actively looking to transform that. And we do that by looking at how humans make decisions in and around physical water supply and the extent to which new data, new models, and decision support mechanisms can help with respect to forecasting, as an example, and whether we can speed up the process by which we address the human water climate nexus. This happens at a variety of scales, from daily, weekly to seasonal and perhaps long-term capital investments, and obviously cascades up from the farm to the district and to the watershed. At UC Merced, we focus on a lot of these, though I would say smart water at the watershed scale is certainly one of our strengths. This is translated into a newly funded project in concert with the AgAid AI Institute, and this is funded by USDA and the Sustainable Agricultural Systems grant, where we are trying to transcend those scales from farm to district to region. And we're doing that to secure a climate resilient water future for agriculture and ecosystems through innovations in measurement management markets. Therein, the data from measurement gets translated into changes in management, and ultimately the opportunity to use water trading or water markets as a mechanism to more equitably distribute that resource. A number of different participants are engaged in this, led by UC Merced. The centerpiece for this particular activity is the individual, whether that's a grower, a district manager, or perhaps an ecosystem manager, being able to take information in the measurements realm, translate those into change in practices, such as managed aquifer recharge or water banking, and then ultimately embedding that information within a larger market context. The translation of data at the regional scale, whether those are different climate services such as the Open ET or Drought Tracker, or perhaps the CMIC-6 projections for climate change, being manifest at 3 different test beds across the semi-arid western United States. One example of this is the Open ET framework, which is our data to be able to fill the biggest unknown in water management in the semi-arid West, and that's around evapotranspiration. Here's an example of a map showing in inches the amount of consumptive use by a particular crop in a particular area. What's novel about this is that it compends the results of 6 different models to show the range of variability across several growing seasons, as well as an ensemble median that can be used to show what is most likely the consensus for the actual consumptive use. We can do that not just for California almonds, but also for New Mexico pecans, and then ultimately translate that into decisions that are being made. And so as we integrate these different technical systems through data dashboards and then ultimately into predictive analytics with artificial intelligence, in effect, this is the future of food as we know it. And we were recently funded by the California Department of Food and Agriculture as part of the Fresno Merced Future of Food Innovation Initiative to focus on climate smart food systems. This F3, if you will, is intended to improve the quality of food and the efficiency of on-farm practices, reduce the application dependence on external inputs, and limit the harmful impacts to humans and the environment. And we focus from producer to consumer with a number of threads that require data turned into better decisions across this value chain. F3 is also inclusive design in so much that the innovation from our university industry partnerships is really intended to break down what has long been structural inequities between innovation and those who benefit from it. So we're focusing on technologies that are affordable and also low risk. We're focusing on making the technology accessible to growers, especially small farmers, but also securing their privacy. The solutions will be multi-benefit and ultimately network so that our cadre of small and medium-sized farmers, as well as local communities of color, can integrate with the innovation and design process in such a way that we assure that the benefits aren't just to those that are developing the technology, but also to those that are using them. These principles of inclusive innovation are important to help break down that paradox. Again, we're talking about bringing technology to one of the most productive agricultural places on the planet, yet one of the most persistently poor. We feel that this approach to ag food tech innovation will be important for all involved. One great example of this is using photovoltaic panels to cover the many canals and aqueducts throughout California. As it turns out, while there is some moderate amount of water savings by reducing the amount of evaporation off of these canals, it actually makes energy production more affordable because the ROI of the photovoltaic is improved due to the cooling that's provided from the evaporation off of the canals to the photovoltaic panels themselves. I encourage you to check out this recent paper led by Brandy McEwen and can be found in Nature Sustainability. To that end, the future of the food is the future of our planet, and we think that these tools and these approaches will be critical as we move forward. Thanks for your time and attention.